So now we'll continue with double tuned amplifiers. As I said, double tuned amplifiers is a very big topic in the derivation point of view. So the difference, if you see with the single tuned and double, in single tuned you just had one inductor, one capacitor at the collector side, but here you see it is double tuned. So I have a pair of inductors and a pair of capacitors in the collector side. So this pair of inductors will be a transformer. So this L1, L2 form a transformer. So primary of the transformer, you have a capacitor in parallel. The secondary, you have a capacitor in parallel, and output from secondary is given to the next stage. And even that stage will have a pair of inductors and a pair of capacitors. So all double tune amplifiers, if you call a cascade n stages of double tune amplifiers, all double tune amplifiers will have this combination at the collector. Rest all things you see, they are same. R1, R2 is biasing resistors. REC, you know it is bypass capacitor and resistance. VSRS is the AC source what you provide. And load is going to be this tank circuit, double tune tank circuit. You see one LC here and another LC here. Both will be tuned to the same frequency. That is a very important constraint you place. L1 C1 dash and L2 C2 dash should be tuned to the same frequency F naught. Or I can say F naught equal to 1 by 2 pi root of L1 C1 dash. F naught is also equal to 1 by 2 pi root of L2 C2 dash. Okay, they both the tuned circuits are tuned to the same resonant frequency. Single tuned, I have only one tank circuit, so there is no, definitely F naught will be 1 by 2 pi root of L1 into C1. But here, since you have two tank circuits in the collector of your amplifier, both it is highly important to ensure that both the tank circuits are tuned to the same resonant frequency F naught. The voltage developed across the tank circuit in the collector side is coupled to another tuned circuit. So here actually the voltage is developed that is coupled to L2 using mutual induction by the transformer phenomenon. And whatever energy is coupled, it is coupled to the base of the second stage of your amplifier. Okay, and see the initial hybrid pi model diagram, everything is same as single tune amplifier. So we directly go to the final stage of your single tune amplifier diagram. So even in exam, if you are going to study double tune amplifier, the simplification need not be shown. Directly you can draw this diagram and show how this is the same as the single tune amplifier. So this is the final output stage of a double tune amplifier. You get this. See, till this is going to be the output. Till this is going to be the single tune amplifier. In single tune, you will be having only this stage. Double tune, extra, you will have one more inductively coupled circuit, which is going to act like a transformer. So we are directly drawing the output equivalent circuit without starting from the first where we draw the hybrid pi model equivalent circuit. Then we apply Miller's theorem. Then amplify the three capacitance into one on both sides. Then we convert. So that and all not there. I'm directly drawing the output side after applying all the Miller's theorem and other concepts. So both the tuned circuits must be tuned to the same frequency. That is very, very important here. So this shows the high frequency small signal equivalent circuit of amplifier.